Okay, so let's start. So we want to look at the endocrine system. First, then we'll look at the nervous system. Clear? The endocrine system is all about endocrine glands, hormones. Huh? The endocrine system is all about hormones. Are we together? How you guys doing?
Yes, sir.
Yes, sir.
Yes, sir.
Gone for holiday. Endocrine system. So what hormones do you know anyway? Let's just start to discuss general hormones. What hormones do you know? The hormones that are found in the human body.
Testosterone.
Correct.
Estrogen.
Insulin, glucagon, adrenaline.
Estrogen.
There are so many hormones. So let's start from the definition of a hormone. What is a hormone? We need to be able to define it. Sometimes it comes with 2 marks. So a hormone is a chemical substance. Is a chemical substance produced by a gland. A chemical substance produced by a gland and carried in the blood, or carried via the blood, carried in the bloodstream. And carried in the bloodstream, which alters, that's the last part that you should never forget, which alters the activity of a specific target organ. So what we used to do, not me, but what other students used to do, I saw them, they did very well for their exams. They used to have like flashcards, flashcards where you write definitions, and maybe you ask your mom or someone to create bio flashcards. Clear? Be good in this definition. Together?
Like what we did in 2019.
Yeah. Are we together? A hormone is a chemical substance produced by a gland and carried in the bloodstream, which alters the activities of a specific target organ. Maybe the key thing here that sometimes I thought maybe you might not find it in the test is that once a hormone is used, it is destroyed by the liver. It is destroyed by the liver. Clear? Once a hormone is used, it is destroyed by the liver. Then the next point is that hormonal effects, the hormonal effects are slower than the nervous system, yes. Slower than nervous system, much slower. But they last longer. long. Clear. That making sense? So before we go, is Ella in the lesson now? Or she's not there?
Wait, hormonal effects are slower than what?
Hormonal effects are slower than they are slower than the nervous system. Or epileptic system, slower than the nervous system. They are slower than the nervous system, but they last longer. Hormonal effects are slower than the nervous system, but they last longer. Are we together? Clear, clear, clear. We can go to the next page. Huh? We are behind time here. So now let's look at, just hold on. I need to sort out this thing, this yellow thing that comes on my screen. Now, let's compare the endocrine system, that's the hormonal system. Huh? Endocrine versus what? That's the nervous system. Huh? You can have something like a table. Yeah.
I said, what are you doing? Because it's very noisy.
So we can have a table. So in terms of the type of signals, what signals are used here? Signals for transmission. Maybe I'll say type of signal here.
Why didn't you come today?
What type of signal is used? There, what type of signal do we use here? Type of signal, it's what? It's chemicals. Hormones are chemicals. Huh? Chemicals. And nervous system is used as electrical what? Electrical impulses. Huh? Electrical impulses. Only chemical at the synapse. We'll talk about that later.
Endocrine.
Are we together? Now, then mode of transport or media. Transmission here is via what? The blood. Huh? Do you agree? Transmission via bloodstream. Then the transmission is via what? What do you think? Those electrical impulses, they are via what? Someone? Transmission, yes, nerve cells or neurons. Transmission via nerve cells. And brackets, we call them neurons. Clear? Then this one, in terms of target or effectors, the effectors, the ones that are responsible for bringing the change. So the effectors, what can you say about this? The effectors are the target cells. Effectors are the target cells in particular tissues. Are we together? Effectors are your target cells. This is your effectors are mainly muscles and glands for the endocrine. Effectors, muscles, or glands. Clear? Then this one, the speed of response is very slow. Speed of response is slow. Then this one, speed of response is very rapid. Clear? Then this one, duration of response is long. Duration of response is long. Then this one, duration of response is short-lived. Duration of response is short-lived. Are we together?
Yes, sir.
Is Ella in the lesson now? She's not there. Maybe network. I think the rest are there. I'm not sure what's happening. Now let's look at some glands now. Glands that secrete hormones. What's known as the master gland in biology? What's known as the master gland, the major gland in biology? What is it? Who knows the master gland? So you need to know glands and their positions. Clear? The glands and their position. The glands and their positions. So I said, what is the master gland? You don't know the master gland? Or you can guess which one
No, Mr. King.
is the master gland? The pituitary gland. Gland is known as the master gland. Clear? Where is it located? Location? Who knows? Is it located in your head, in your liver, heart, whatever? It's located where in the brain, huh? Location, brain. It secretes several hormones. Huh? You can write that it secretes several hormones. That's the reason why it's not. It secretes several hormones. Several hormones into the bloodstream altogether. Depending on the response. Are we together?
Yeah.
What other gland do we have besides this one? We've got the what? The thyroid what? Gland. Clear? Thyroid gland. Produces. This is not a very important one. Thyroxine. hormone. Clear?
Shit.
That yellow thing, why is it coming up and distracting my lesson?
Choose thyroid mine what?
Sorry? It produces thyroxine hormone. Important glands. We also have the what? Another very important one is pancreas. It produces two hormones. What are the two hormones? Insulin, clear, and glucagon. They control sugar level. We'll talk about that. Clear? Insulin and glucagon. We have got the adrenal gland.
What's that word? What's the last word on number 2? That's what I can't really read that.
Pancreas.
Okay.
Then we have the adrenal gland. So yes, we are talking of adrenaline. Huh? When is our next bio lesson?
Friday.
It was Friday. Adrenaline. Then what are the glands? Important glands. Someone mentioned that the testes. They produce what? Is that the correct spelling? Then of course you've got your ovaries. Which produce estrogen. Are we together then? No, I'm just looking at the time here. We don't have much time. I thought we were going to cover much, but I see we don't have much time. Let's talk of adrenaline here. What are the target organs that adrenaline affects? Huh? What are the targeted organs? It includes what? Your respiratory and circulatory system. Huh? Systems. Huh? And let's look at the effects, which are obvious. Most of you know them. The effects, they increases what? Breathing rate. Huh? Increases breathing rate. Increases heart rate. Huh? Clear? increases flow of blood to muscles. Huh? Clear? Increases conversion of glycogen to glucose. Now, what's the main function of adrenaline? Who can tell me the main function of adrenaline? Why is it doing this? Adrenaline, its main function is to preparation for a fight. Huh? Are we together?
Yes, sir.
Oh yeah, I lost.
No.
Now, the rest, don't worry about them. The rest to look as with reproduction, we've learned about the other hormones. Now let's look at negative feedback mechanism. Negative feedback mechanism. Negative feedback mechanism. So I'll just do a diagram here, which you can follow. So we're talking of, in general, I'll explain it just now before we look at the next lesson. I think is we'll switch on just now. So conditions in body change from set point. Body change from set point. Then the change is detected. Then when the change is detected, corrective mechanisms are implemented. Corrective this yellow thing again. I need to sort it out. Corrective mechanisms are implemented. Corrective mechanisms. So you can write what I said. Corrective mechanisms, don't wait for me, are implemented. Clear? Corrective mechanisms are implemented. Then conditions returned to set point. Conditions returned to set point. Corrective mechanisms switched off. We no longer need them. Corrective mechanisms switched off. Then we are back to this here. Is that making sense?
Yes, sir.
So before the chemistry lesson, let's look at one thing. Then we look at this. The control of the sugar level. So the normal for a normal person, you don't have to remember the value. Huh? Normal sugar level is said to be about 180 milligrams, depending on the books, per 100 cubic centimeters of blood. Yeah? Clear. Are we together then? Now, when do you have too much sugar in the body? What condition leads to too much sugar in the blood? So we'll start when there's too much sugar. When do you have too much sugar? So when you eat what? When you eat a meal rich in what? Carbohydrates. Huh? Because carbohydrates eventually they're going to be digested to glucose. Huh? Some glucose will be used by respiration, but some glucose will increase the what? The sugar level in the what? Hi, how are you? So some glucose will increase the sugar level in the blood. Are we together? So you're saying when you eat a meal rich in, when you eat but it takes time to digest when you eat a meal rich in carbohydrates. So the first thing, now let's look at the negative mechanism. So that will lead to an increase. So this leads to an increase in sugar level after digestion. Clear? Increase in sugar level. So the body has to detect that. Clear? Remember, so we talked about negative. So what detects the sugar level is not the brain, it's the pancreas. Huh? So the pancreas detects stimuli. Stimuli is the change. Huh? It detects stimuli. In this term, we're saying the rise in glucose level in the blood. Clear? Then, so the insulin now, because it detects, the body has to come up with a corrective what? Mechanism. Huh? So the pancreas secretes a hormone called insulin. A hormone called what? Insulin. Are we together? Secretes a hormone called insulin. Making sense? Next point
Yes, sir.
is that the insulin is transported to the liver via the blood. Once it reaches the liver, the insulin converts excess glucose to glycogen, which is insoluble. Clear? The glucose level returns to normal. Glucose level to normal. Is that clear? So let's say, don't write this, 120 milligrams per 100 cubic. I just want to illustrate this. If the glucose level has gone up to 220, which is not healthy for that to stay long, it can cause damage to the brain cells, so like that. So immediately insulin is secreted. The insulin, what's the excess here? It's 40 milligrams. Huh? So the insulin, when I'm saying it converts the glycogen, it converts the glucose, it has to convert the excess glucose. It converts the 40 milligrams glycogen. Huh? The glycogen does not, it's insoluble in blood, so it's fine. Huh? It's stored in the liver. Then once it converts this, it means your glucose level goes back to it, to normal. Is that making sense? That's what you're talking about. Huh? Then now, the last thing before we switch on to chemistry, when sugar level
Hello.
is low, what causes sugar level to be low? Biology. What causes sugar level to be low? When you exercise, respiration. Huh? Because respiration, remember, converts your, uses up your respiration, uses up your what? So, clear? So, respiration uses up the glucose. Huh? Clear? Especially during exercising. Huh? Exercises. When you do that, you use up glucose. Huh? Now, so because you're not eating, you're exercising, you're doing something that is using up the glucose, the body has to come up with what? It has to come up with a mechanism where it has to restore on its own. Yeah? Now, look at this. The pancreas detects that. Basically, the pancreas detects the stimuli, yeah? Which is a decrease in sugar level. Now, pancreas secretes a hormone called glucagon. Clear? In the beta cells, the glucagon travels to the liver via the blood. Via the blood. Yeah? Now, once the glucagon reaches the liver, it converts glycogen. Huh? Remember, we've got glycogen as an energy backup. It converts the glycogen to glucose. Clear? Converts the glycogen to glucose. Then the next thing you're going to say that the glucose is secreted. The glucose is secreted into the bloodstream to restore the sugar level. Clear? To restore the glucose level to normal. The last point is that the glucose is now secreted, that has been converted into the bloodstream to restore the glucose level to normal. Not difficult. Clear? So your homework is to go and look. We have issues where your insulin is malfunctioning, which leads to type 1 and type 2. Go and read on type 1 and type 2 diabetes before the next lesson. Clear? Let's switch to chemistry. We are done for bio.
Thank you, sir.
You're welcome.
Thanks, sir.
Okay.